section 6.2. We're looking at the sum difference in double angle identities today. We're going to split up this section into two parts once again just to help you guys out. And I thought we would start today's lesson by going back to something you learned way back, and that's simplifying these expressions. Okay? How about part A here? Simplify 3x times x squared minus 2. We've got these brackets, and I guess when we simplify, we want to get rid of the brackets. So we distribute. Hopefully you remember this. That's 3x cubed. And then 3x times 2, that's negative 6x. Okay? Something similar over here with signs. So what do you think is going to happen here? And if you're thinking, let's distribute, okay, let's find out. So that's sine x minus sine y. Now, for part B, let's check our results by substituting values for x and y, okay, to see if we're correct. Let's use some of those special angles that we know. I'm just going to randomly choose, let's say x is 30, and I don't know, let's say y is equal to, let's use 60, okay? So, let's go ahead and use what we did over there. So sine of 30 minus 60. And that's supposed to be equal to sine of 30 take away sine of 60. Okay? My left-hand side is now simplified to sine of negative 30. Once again, these are degrees. And if we were to figure out what that value is, remember our special angle tables and all that kind of stuff. Here's 30 degrees. That's pi over 6 if you like radians. And then if we were to do sine of pi over 6 or 30 degrees, we get a half. Because this is in quadrant number 4, all students take calculus, this must be negative half. Well, let's see if the right-hand side is also the same thing. Sine 30 we know is just 1/2. Sine 60 I believe is root 3 over 2. When I subtract these, I get 1 minus root 3 all over 2. That doesn't seem to be equal to negative 1/2, so I think we've got a problem. So I think what I want you to understand here is that the distributive property does not work for trig functions. Okay? Actually, for functions in general, a function just doesn't work that way. So, how do we expand something like this, where it's sine of x take away y? By the way, this is what they call a difference, because you're taking two things and you're subtracting them. So how do we do that? Okay. Well, to do so, what we do in trig is we apply these various sum and difference identities. Okay. I'm not going to prove them for you right now, at least the sum identities, because, well, it's a lot of work and I think most of you probably don't care about that stuff anyways. So I'm just going to tell you this. If you really do want to know, come find me and we'll do it together. But there's a sum identity. So if I have sine of an angle A plus another angle B, it's actually equal to sine of the angle A times cosine of the angle B plus cos of the angle A times sine of the angle B. Okay? Cosine has another one too. Cosine of A plus B, that's equal to cos A times cos B minus sine A sine B. And a tangent one, which is not used very often, but I'm going to show you anyways. Tangent A plus B is equal to tangent A plus tangent B all over 1 subtracting the tangent A multiplied by the tangent B. Okay? So these are the sum identities. Now, in example 1, I want us to use the sine and cosine sum identities to find the corresponding difference identities by changing the b to become negative b. Now, before I do that, I'd like you to take a look to the right here, and let's just think back to what sine of negative theta is actually equal to. Now, go back to chapter 5, and I hope you remember from chapter 5, if I gave you y equals to sine theta, you get a nice lovely graph that starts at 0, goes up to 1, back to 0, down to negative 1, ends at 0. Remember that? Good. What do you think happens when I do sine of negative theta? Well, that negative there means what? Yeah, that negative means you do a reflection in the y-axis, right? So if I were to actually use now y equals to sine negative theta, once again, this is a reflection in the y-axis, that red graph becomes this green one. Now remember how the red graph is actually periodic, goes on forever and ever. So if I were to compare now the red with the green, notice that it seems to be the same as a reflection in the y-axis. So ultimately what I want you to understand here is that sine negative theta is the same thing as negative sine theta, because we just said that this is the same as a reflection in the x-axis. Okay? We're going to use that in a second, example number 1. So put a cloud around it. It's important. Similarly, with cosine, let's see what that one will look like. Cosine theta, I believe, starts at 1, goes 0, negative 1, back to 0, and then 1. I'll graph out another function, another cycle. If I were to just take this part and ask you to now apply y equals to cosine of negative theta, once again a reflection in the y-axis, taking that part I highlighted and reflecting the y-axis seems to mean that you get the exact same graph. And so therefore in this particular case, for cosine of negative theta, that's just equal to the same cosine graph. Okay? And this is going to come in handy once again in example number 1. So let's put a cloud around that too. Okay, so now we're ready to take a look at these. Okay, so I'm going to ask us to do sine first. So instead of having sine a plus b, because I'm asking you to substitute b for negative b, this now becomes sine a plus negative b, or a minus b. Now what that means is in each of these terms above here, wherever I see b, I will replace it with negative b. So sine a, cosine negative b. By the way, I hope you know where I'm looking at. I'm looking up here right now, okay? Plus cos a sine negative b. Okay? Now, let's see if we can simplify these. Sine A stays the same, but what's cosine of negative B? Well, if you look to the right in the box, cosine of negative theta over here, which I'll highlight in purple now, is equal to actually the cosine of theta. So cosine of negative B must just equal to cosine of B. And then we have plus cos A. And sine negative B, looking over here, and I'll highlight that in blue, seems to be equal to negative sine theta, so I'll put in negative sine of the b. A positive times a negative, of course, just means it's a negative. So ultimately what I have here is sine a cos b minus cos a sine b. Okay, there's the first difference identity. Okay. All right. Let's do the same now for cosine. Okay. So cos, once again, cos a plus b is what we're starting with, but we're going to change that to cos a, and then instead of positive b, it's now negative b. We'll use the formula, and that's from above. So let me go back up here, take a look. Cos A, B, sine A, B. So I'll write down cos A, cos negative B, plus sine A and sine negative B. Okay? We'll make the same substitutions with the clouds in blue and purple. So we get cos A, cos B, plus sine A and negative sine B. And of course, this just simplifies to cos A, cos B, minus. I think I made a mistake, didn't I? Where's my mistake, everybody? Oh, yes. This plus was not actually plus. What was it? Let's go back. Oh yeah, it's minus. Oopsies. Let's erase. Erase. Minus. Minus. And so the two negatives actually become a positive now. That makes sense. Sine A, sine B. And sorry about that quick glitch, but now we've got the difference identity for cosine. So let me write them down in this box here so that we have all this information in one handy place. And notice I'm not going to make you do this for tangent because, well, I just don't want to. We've done 2 already. You get the idea. Okay? Alright. So today we're going to use these formulas to help us simplify and take a look at some identities. And to do that, let's turn the page to page 2. Alright. Well, here's something interesting, example number 1. I've given you this nice long trig expression involving sine, cos, and all that kind of stuff. Your job here is to try to simplify and write this as one single trig expression. Now notice the first one, it seems like I have sine of an angle, kind of like sine A, then cosine a different angle B, plus cosine of A, sine of B. Now where have you seen this before? And if you say, hey, this seems to be like, hey, the addition or sum identity, sine A plus B, you are totally correct. Well, what is A in this case? It seems like it's the number 24, and B seems to be the number 55. So we'll add that together. We'll just say sine 24 plus 55. That's sine 79 degrees. And that's it. There's your simplified trig expression. Okay? Do the same thing now for part B and C. Let's see if you can do this on your own. Okay? Compare if you dare. This one seems to be cosine of A minus B. That's just cosine of 120 minus 60. And that's just cosine of 60 degrees. Okay? Tangent. So once again, go back to the first page and look at where this ugly expression is. And I'll tell you that this looks like one of those difference identities. Since it involves tangent, it's probably the difference in tangent. So A minus B, that's tangent of pi over 3 minus pi over 4. And by the way, we need the same denominator. 4 pi minus 3 pi. So how about tangent? 4 minus 3 is just 1, so pi over 12. There you go. Okay. So here's where we made a really complicated thing look simple. And now in example number 2, I'm going to ask you to try to evaluate something that's simple and give it to me in exact form. In the past, we'd be plugging this into the graphing calculator or the calculator, you get a decimal. Well, now I'm saying some of these you can actually do in exact form. And why? It's all because of that special angle table. And by the way, if you're not too sure what that is, let me quickly remind you what they are. We've got here, I think, 0, which most people don't care about, 30, 45, 60, and 90. How about sine, cosine, and tangent? Remember these values, everybody? Sine 0, 0. Yeah, sine 30 is a half. Then we had root 2 over 2, root 3 over 2, and this is root 4 over 2, or just 1. Remember this? And cosine is just backwards, so you go 1, root 3 over 2, root 2 over 2, 1 over 2, 0. Remember how I told you in chapter 4 this stuff's going to come back? Well, guess what? It's coming back again. How about tangent? Well, that's just sine over cos, so that's 0. 1 over root 3, 1, root 3, undefined. Ah, yes, it's back. Alright, so how are we going to do stuff like this? It says find an exact expression for the following. Sine of 5 pi over 12. Wow, how can we create 5 pi over 12? Either by adding things together or subtracting things together. Now, the key here is to use one of these special angles to help us out, because we know the exact values for the special angles. How can you get 5 pi over 12? Well, I guess you have to find a common denominator. I guess 4 and 3 give you 12. I guess 6 and 2. Well, the common denominator is 6. So probably the 4 and the 3. So my bet would be if to get 12, I'm going to have to use pi over 4 and pi over 3 somehow. Anything? Any suggestions? This is tough, eh? Well, let's see. If you did do pi over 4 and pi over 3, let's see what you get. Okay, just watch me first. Don't write this down. Sine of pi over 4 plus pi over 3. If we did actually use this, then I guess we have the common denominator. That would be 3 pi. And this would be 4 pi. And that's actually 7 pi. Oops, that's not right. I want 5 pi. Oopsies. Well, I guess I don't want 4 pi, but I actually want 2 pi. So ultimately I want this thing here to be 2 pi. Well, how do I get 2 pi over 12? Well, that seems to be, if I simplify it, to be pi over 6. Right? Pi over 6 is equal to 2 pi over 12. So I think what we just found out here, and please write this down then, is that sine 5 pi over 12 is the same thing as sine of pi over 4 plus pi over 6. And once you found that, then you have your expressions for a and b, and hey, life is pretty straightforward now. Just go ahead and plug it into those sum or difference identities, and let's see if we can find what the exact value is going to be. So we will do this by saying this is sine of a, which is pi over 4, times cosine of b, which is pi over 6, plus cosine of a, which is pi over 4, times sine of pi over 6. Now go to your special angle table and evaluate. Sine pi over 4, that seems to be root 2 over 2. Cosine pi over 6, that's 30 degrees, that's just root 3 over 2. Cosine of pi over 4, that's root 2 over 2. Sine of pi over 6, that's 1/2, is just 1/2. And if I ask you to simplify this, what we have here is root 2 times root 3 is root 6 over 4. Root 2 times 1 is just root 2 over 4. Since everything is over 4, we can combine the numerators together, and there you have it. This is sine of 5 pi over 12 as an exact value. Okay? The rest of these are the same thing. The tricky part is the first step, how you can create the angle by either adding or subtracting these special angles. Okay, think about cosine 165. Think about what you can do to get 165. Okay, I'll let you think about that first. Take at least 20 seconds, okay? Go. Okay, I've taken 20 seconds. I know that wasn't 20 seconds, but whatever. It's 20 seconds. Any suggestions here for what two things either add or subtract to 165? Once again, this is the hardest part, okay? But I'm going to tell you this would be the same thing as cosine. Now, since I know it ends in 5, guess what? I know they're going to be a 45 degree for sure. And then I thought to myself, okay, well, what's 165 minus 45? Well, that's 120. And even though 120 might not be actually in this chart above, I do know that I can find cosine 120 pretty simply because the reference angle is 60 degrees. Okay? Yes, all that stuff from chapter 4 coming back to haunt you. I told you so. Did I say that again? Can I say that again? I told you so. So let's continue to do this then. We'll use the cosine addition identity. That'd be cosine of 45, cosine of 120, minus sine of 45, sine of 120. Okay? Now, remember, cos of 120 is the same thing as cosine of 60, but because we're in quadrant 2, it's negative. Okay, so I just want you to be aware of that. And sine of 120, well, that reference angle is 60, but because it's in quadrant 2 and sine's positive, we just leave it as positive. And so now once you've done that, you can go to your special angle table and find the numbers. Cosine of 45 degrees, root 2 over 2. Cosine of 60 is 1/2, but this is negative, so I'll put down negative 1/2. Minus sine of 45, which is just root 2 over 2. And sine of 60, which is root 3 over 2. And if we simplify this, we get negative root 2 minus root 6 all over 4. That's cosine 165. Alright, let's try C. Pi over 12. So once again, you got to do something about this. 1 pi over 12. So think pi over 12, 4 and 3, 4 and 6, I don't know, something like that. You think about what you can do. And while you do that, I will start actually working this out. Once again, the hardest part is knowing if it's adding or subtracting, and this just takes practice, okay? So think about this. I would think pi over 3 minus pi over 4. Right, 12. Gotta use 3 and 4, or it's 4 and 6. One of those denominators. Not too sure, by the way. Pi over 3 minus pi over 4. If I wrote down the denominator being 12, 4 pi minus 3 pi, oh yeah, that's pi over 12. That's where it comes from. Okay? Let's go ahead and use the difference identity for tangent. So that would be tangent of A, pi over 3, minus tangent of pi over 4, all over 1 plus tangent of A, which would be pi over 3, tangent pi over 4. Okay? Weren't too sure what those were? Go back to your chart. Pi over 3 is 60, so tangent of 60 is root 3. Okay? Here's root 3. Tangent pi over 4 is 45, that's just 1. 1 plus, I think, root 3 times 1. So here we have it, root 3 minus 1 over 1 plus root 3. Done. And for those of you math sticklers, you want to rationalize the denominator, you can. You don't have to, but you can always rationalize if you don't like having the root 3 in the bottom. We do that by multiplying by its conjugate, which is just the same two terms, but the sign is different. We'll distribute. And by the way, you don't need to do this, but some of you might like to. All over 1 minus 3. And I think the top part becomes 2 root 3 minus 4. This is over negative 2. We'll factor out the 2. Divide out. How about negative root 3 plus 2? Okay. Once again, this stuff in purple, not that necessary. It's not really the trig stuff. If you can get that answer in black right here, that's perfectly fine, or I'll take that too. Okay? Alright, let's do the last one, D. This one's a little bit different because this one doesn't have an angle. It actually has two things already. So it says cosine theta plus 2. There's already those two angles. So notice you already have your A and you already have your B. Just go ahead and actually put it into the formula. So no need to break it up. It's already been done. Cos theta, cos pi over 2, minus sine theta sine pi over 2. Now here you should be able to evaluate the cos pi over 2 and the sine pi over 2. Pi over 2 is 90, cosine of 90 degrees, I believe, is just 0. So this becomes cosine theta times 0 minus sine theta, and pi over 2 is, I think, just 1. So what we have here is just this equals to negative sine theta. And that's it. Okay. All right. One last example here, and then we'll call it a day. This one says, given that you have these two angles and these two trig functions, cos A equals to negative 4/5 and sine B is 12/13, and notice it says both angle A and angle B are in quadrant 2. They want you to evaluate each expression, and the expressions below are sine A minus B, cos A plus B, tan A plus B. Now, before I even draw these pictures, what's sine A minus B? Well, by our formulas on the first page, that's sine A cos B minus cos A and sine B. So even looking at this, what we need to do is figure out the ratio sine A cos A and sine B cos B. And to do that, we're going to go back up here. Okay? Remember, this is in quadrant 2, so I'm going to draw a picture. Quadrant 2. Because this is negative 4/5, I think what that means is that the x value must be negative 4, and the radius must be equal to 5, so we have to figure out that y value. Good old Pythagoras to the rescue. Negative 4 squared plus y squared equals to 5 squared. And many of you already know that this would be 25 minus 16, or 9, so y equals to 3. Why not negative 3? Yes, because we're in quadrant number 2. So if that's the case, what we know is cosine A equals negative 4/5. From here we can also figure out what sine of angle A is going to be then. So sine, of course, by definition is y over r, so the y value is 3, the r value is 5. We can also calculate tangent of A, which we'll need in a second. That's y over x, so that's just 3 over negative 4. Okay? So I'm going to ask you to do something similar for sine B, and I don't want to do it for you. I want you to try it out on your own. So stop the tape and try drawing it out and see if you can come up with the same, or not the same, but the similar ratios for cosine B and also for tangent B. Okay? Go ahead, try. Notice in this case, though, x is not 5, but it should be negative 5 because we're in quadrant number 2. So cosine is just x over r, that'd be negative 5 over 13. Tangent's y over x, so that's just 12 over negative 5. Okay? Once you got all these ratios, now we can actually start evaluating these things underneath. Okay? What's sine A again? Well, you just look up top. Sine A seems to be the fraction 3/5. What's cosine B? Well, that seems to be the fraction negative 5 over 13. Well, minus cosine A, which is just negative 4/5. And sine B, which is just 12 over 13. And I'm going to ask you to please simplify these. So 3 times 5, oh, actually, yeah, I'll do that. 3 times 5 is negative 15. 5 times 13 is 65. 2 negatives become a positive. 4 times 12 is 48 over 65. Negative 15 plus 48 is just 33 over 65. And there's your answer. Okay? I showed you how to do it. Why don't you try part B and you try part C, because the ideas are the same. Okay? Cosine A plus B, sorry. Go ahead and use the sum identities. Cos A, cos B, minus sine A, sine b. Evaluate. Cos A. What was cos A? Oh yeah, negative 4/5. Cos B. I believe that was negative 5/13. Minus sine A, which I believe was 3/5. Sine B, which was 12/13. Negative 4 times negative 5 is 20, so 20/65. Minus 3 times 12 is 36/65. Probably negative 16/65. Yeah. Okay. And last but not least, good old tangent A plus B. So we'll go back and use the formula. That's just tangent of A plus the tangent of B all over 1 minus the tangent of A times the tangent of B. Where did I get this from? Go back to page 1. Okay. What's tangent of A though? So look back up top. Tangent A seems to be, well, where is it? 3/-4. Okay, so negative 3/4. Oh, I should have went back and looked for tangent B. Where is tangent B? There it is. 12/-5. Okay. And the bottom becomes 1 minus negative 3/4 times negative 12/5. Alright, let's simplify. The numerator needs the same common denominator. That would be 20. The bottom, we've got minus, minus, minus. Well, lots of minuses. 3 times 12 is 36/20, I guess. So let's try to simplify this even further. 48/15, how about negative 63/20? And here, the 1 is the same thing as 20/20, so 20 minus 36 must be negative 16/20. We can simplify this, because that's the same thing as negative 63/20 divided by negative 16/20, which is the same thing as taking the first fraction and multiplying it by the reciprocal of the second. Luckily, those 20s divide out, and I believe we just have 63/16. Yay! We're done.